This is a presentation and demonstration of live patching the RHEL kernel with kpatch. Kernel live patching is a technology developed to address a particular issue that IT administrators face when applying security updates to their systems. The problem is that security updates are just a part of IT reality. While all security updates are disruptive to some degree, updates to the kernel are particularly disruptive because they require a reboot in order to take effect. Most systems running workloads that don't scale out can't be taken down at arbitrary times. A downtime window must be scheduled and the system remains vulnerable until it can be rebooted. Kernel live patching was developed to address this issue. The primary benefit of kernel live patching is the ability to apply security fixes to the running kernel without the need to reboot. There is minimal disruption to the system, and the update is transparent to the applications. We also use the existing package management system to roll out these live updates. Cases in which this ability is useful include systems running a dedicated workload or systems running a workload that the administrator doesn't directly control, such as a hypervisor or container host. Taking these machines down is very difficult and disruptive unless the underlying virtualization or containerization technology is set up for live migration, which requires an additional level of complexity. This diagram illustrates the process. Before the live patch is applied, there is just the old function with the first instruction being a no-op. This no-op is inserted by the compiler at build time as a hook for ftrace. When a live patch is loaded, any patched function is registered with ftrace, which replaces the no-op with a call instruction in order to intercept the calls made to the old function. Kpatch then adjusts the return address so that the ftrace handler returns to the new function instead of the old one. The new function then returns to the original caller of the old function. This is a demonstration of the process from the user perspective. This machine is running an old kernel version that has a known vulnerability that is exploited by the program named exploit. This exploit is a denial of service, so when run, it will either crash or hang the system. The machine has stopped replying to echo requests, indicating that the machine has been successfully exploited. To protect against the vulnerability, we install the live patch developed for this kernel version. This is done by installing the kpatch and kpatch patch packages. Once the installation is complete, the live patches have already been applied and the system isn't vulnerable to this attack. The kpatch list command will show the installed and loaded live patches. Now the exploit program is handled correctly by the system. Kernel live patches are installed and updated using the package manager. The kpatch command provides a simple CLI for managing live patches on the system.